You know, the AI tools we use every single day, the ones that can write code or a poem or plan your vacation, they really do feel like magic, don't they? But how do they actually pull it off? Well, today, we're going to pull back the curtain on the one piece of technology that made all of this possible, the transformer.
And it's kind of wild, but it all comes down to this. At the very heart of these insanely complex systems is one almost ridiculously simple goal. Just predict the next word. Seriously, that's it. All the incredible stuff they can do just emerges from getting really, really good at that one thing.
All right, so here's our game plan. First, we'll look at the big problem that was holding AI back. Then, the breakthrough that changed everything. We'll talk about the wild race to build bigger and bigger models, the new wall everyone's hitting, and finally, what the exciting next chapter of AI might look like.
So, before 2017, AI language models had a really big problem. They had, for lack of a better term, terrible memories. Imagine trying to read a book, but by the time you reach the end of a page, you've totally forgotten what was at the top. That's what these models were doing, losing crucial context all the time.
The old way of doing things involved something called a recurrent neural network, or an RNN, and it tried to read just like us, one word at a time. The problem, as we said, was that it would forget the beginning of a long sentence. But then the transformer came along and just flipped the entire script. Instead of reading word by word, it looks at the entire sentence all at once in a single snapshot. It was a complete paradigm shift.
And that huge shift came from this one landmark research paper out of Google back in 2017. It wasn't just another model. It introduced a totally new idea, a mechanism called self-attention that would, no exaggeration, become the engine for all of modern AI.
And the title of the paper, wow. Attention is all you need. That wasn't just a clever name. It was a shot across the bow. They were basically saying, hey, all that complicated stuff you've been doing, you can throw it out. This one core idea is all you need. And you know what? They were right. It completely changed the game.
So how does this magical self-attention actually work? Okay, stick with me here. It's brilliant. For every single word, the model creates three things. First, a query. You can think of this as the word asking a question. Hey, who in this sentence is important to me? Then it compares that question to a key from every other word. If a key is a good match for the query, it gets a high score. And finally, the model grabs the value, the actual substance of the word, from the words that got the highest scores. It's like every word gets its own spotlight to shine on the other words that give it meaning.
Once researchers had this new superpower, oh man, the floodgates just burst open. The entire industry kicked off a massive race to see who could build the biggest, baddest transformer model. In this relentless race for scale, it's the reason we have the amazing AI tools we're all using today.
And when I say scale, the numbers are just mind-bending. We went from models with millions of parameters to billions, and now we're seeing models with over 200 billion parameters. You can think of each parameter as a tiny little knob that the AI tunes during training. The more knobs you have, the more sophisticated and knowledgeable the model can become.
But there's always the but, right? There's a huge catch. Training and running these gigantic models costs an absolute fortune and uses a staggering amount of energy. So just building bigger wasn't going to cut it. They had to get smarter.
And that need for smarter scaling led to this incredible idea, the mixture of experts architecture. The concept is genius. Instead of one giant monolithic brain, you build a huge model out of lots of smaller expert networks. Then, when a question comes in, you don't bother the whole team. You just route it to the 2 or 3 experts who are best suited for that specific job.
And the efficiency gains are just massive. Look at this. A traditional or dense model has to fire up 100% of its brainpower for every single little thing. It's all or nothing. But a mixture of experts model might only need to activate, say, 15% of its total power. So you get all the knowledge of a massive model, but with the running costs of a much, much smaller one. It's a total game changer.
Okay, so everything's looking great. We're building bigger models, but we're doing it more efficiently. What could go wrong? Well, a fundamental problem started to creep in. And ironically, the issue was with the attention mechanism itself, the very thing that made transformers so powerful in the first place.
Which leads us to this fascinating, almost poetic question. That amazing ability for every word to pay attention to every other word. Is that superpower also its Achilles heel? Because it turns out that incredible ability comes with a very, very steep price tag.
Now, this might look a little technical, but the concept is actually pretty straightforward. It's called the quadratic scaling problem, and here's all you need to remember. If you double the length of the text you're giving an AI, it doesn't do double the work. Nope, it does 4 times the work. If you make the text 10 times longer, it's 100 times the work. You can see how this spirals out of control really, really fast and makes it almost impossible to process something like an entire book.
So the multi-billion-dollar question in AI right now is, how do we break through that quadratic wall? And that question is driving all of the most exciting research today. We're seeing a whole new wave of ideas and architectures designed to solve this exact problem and kick off the next chapter in AI.
The holy grail is something called linear scaling. It's the dream. Double the text, you only double the work. Simple, efficient, and sustainable. And the top contenders to make this dream a reality are a whole new class of models called state space models, or SSMs. You might have heard of one called Mamba. These are the models that are seriously challenging the Transformers throne.
But what's really fascinating is that the future isn't a winner-take-all fight. It's shaping up to be this really diverse ecosystem. You've got these super efficient state space models for long documents. You've got clever hybrid models that try to get the best of both worlds. You even have people who are finding new ways to make the original attention mechanism better. And of course, tiny little models designed to run right on your phone.
And you know, the innovation isn't just about the architecture. It's also about how we're thinking about using these things. We're moving from simple chatbots to what people are calling AI agents, models that can plan and actually do complex tasks for you. We're focused on building safety right into the core of the models, pushing for real reasoning instead of just clever pattern matching, and realizing that at the end of the day, the quality of your data might be the most important thing of all.
So when you just step back for a second, from the early days of models with bad memory, to the absolute magic of self-attention, through the wild race for scale, and now to this new challenge of the quadratic wall, it has been an absolutely incredible journey. We're at a real turning point. The Transformer gave us this AI revolution. And that leaves us with one huge, exciting question to think about.